5.2, evaluate and graph polynomial functions. That looks very weird. Okay, so the first problems that we're going to be looking at want us to say if it's a polynomial function or not. If it is, we need to write it in standard form if it's not already written that way, meaning the terms are in descending order. And then we're going to state the degree, type, and leading coefficient. So for f of x is equal to 6x plus 8x to the fourth minus 3. So essentially, for it to be polynomial, I don't know if you had these rules in here or not. You did not. You essentially have to just have your variable raised to essentially like whole number exponents. We can't have like radical exponents and things like that. Or not like radical, but like where it would cause a radical. So we can't have fraction exponents. And we can't have negative exponents. And we can't have a variable as an exponent. Okay, so this one would be polynomial because I have an x to the 1 and an x to the 4, and this essentially is my x to the 0, which we don't really ever think about it that way. So I need to rewrite these in descending order. So it's going to be f of x is equal to 8x to the fourth plus 6x minus 3. So this is polynomial. And then degree is whatever our highest powered exponent is. So what is our highest powered exponent? 4. And then the type is the name for that. So you had a whole table of them.
Quartic.
Yep. So if it's degree 4, it is quartic. If it's something that's not in your table, I don't expect you to know it. So basically you just need to know 0 through 4 because that was all that was in there. And then the leading coefficient is always the number in front of your highest powered term. So that's why I say write it in standard form first, because a lot of times people think leading coefficient is the first number that's written, which it kind of is, but only when it's in standard form. So the leading coefficient is going to be 8. Any questions about that? All right, 6. What?
It's a graph of that.
No.
We could, but we're not going to.
It's not a graph.
Trying to get through chapter 5 before Christmas, so then we won't get through all of it, but we're going to get through most of it. H of x equals x cubed times the square root of 10 plus 5x to the negative 2 plus 1. All right, now.
Quadratic.
Why?
Wait, no, it's not a polynomial function.
Correct.
Because it's a negative 2.
Yep. So just for your reference, this being the square root of 10 is not a problem. The square root of 10 normally would just be written in front. They just do it, if you remember me talking about, I don't like to put the stuff after because it looks like it's underneath. So just so that you're eliminating the confusion, that's why they wrote it after. But this is the problem right here because I have a negative exponent. So this is not polynomial. And then you just would say y and just say negative exponent. Eight.
Everyone's getting a haircut.
Jack
Is it like the new style now? You're going away from the long hair?
Oh, yeah.
All right. G of x equals 8x cubed minus 4x squared plus 2 over x. Why? Yep, I can't have a variable in the denominator because what this really would be is 8x cubed minus 4x squared plus 2x to the negative 1. And because we can move it with our exponent, and so this would cause a negative exponent, or like what you said, if you say there's a variable in the denominator, that would also be fine. So not polynomial. Either say variable in the denominator or negative exponent.
Denominator's a long word.
Okay. The next problem is going to be the hardest thing you've done all year. It's direct substitution. We literally are just plugging in a number and solving. All right, now there's going to be two different types of substitution that we're going to do. We're starting out with direct substitution, and then we're going to go to synthetic substitution, which is what's going to help us going forward in other stuff. So I actually like synthetic a little bit more than direct, and you probably will end up as well liking it more, but it just depends. But with direct substitution, I'm literally just taking the x value that they give me and plugging it into the equation and getting a number. So number 10, f of x is equal to 8x plus 5x to the fourth minus 3x squared minus x cubed, and x is equal to 2. So everywhere I see an x, I'm going to put a 2. So I have 8 times 2 plus 5 times 2 to the fourth minus 3 times 2 squared minus 2 cubed. I usually use parentheses when I'm substituting. Not really that big of a deal since it's a positive value, but if it was negative, I would definitely use parentheses. So 8 times 2 is 16. 2 to the fourth is 16 times 5 is 80.
80, yeah.
And then,
Negative 12.
yep. And then,
87.
what? Oh, are you saying the final answer? Oh, I was like, what?
No, 2 times 2 times 2 is not 7.
Yeah, so then 76.
That's it.
Yep. 14 g of x equals 4x to the fifth plus 6x cubed plus x squared minus 10x plus 5. X equals negative 2.
You should put like 10.
What?
You should put like 10.
Fortunately, they're pretty much giving you like smaller numbers to deal with just because in theory you're supposed to be doing this without a calculator. All right, so 4 times negative 2 to the fifth, and I've got to make sure I watch those signs on the power so that I know if it's supposed to be positive or negative, plus 6 times negative 2 cubed, plus negative 2 squared, minus 10 times negative 2, plus 5. All right, negative 2 to the fifth is what?
Negative 32.
Yep. No, I'm just going to do this for the moment, but
Negative 128.
yep, so negative 128. All right, and then negative 2 cubed,
Negative 8.
so 6 times negative 8 is
48.
48.
negative 48. And then essentially I'm just doing the intermediate steps here that I don't really need to show. Yep, plus 4.
Plus 25.
Yep. I'm just going to go straight down here. So I essentially didn't need to do that middle step. I was just writing it so we could see the stuff happening. All right, so then
Negative 176, 172 plus 25.
176.
147.
Yes, negative 147.
Okay.
All right, so pretty easy, other than it's requiring you to remember some of your basic math, right?
Yeah, that's hay way from
All right, we're going to move to synthetic substitution because that stuff should have been pretty easy. Now, if you're struggling with this, like, basic, like, adding this stuff up kind of thing, then you're going to like synthetic a lot better, okay? The difference with synthetic is your terms have to be in descending order.
Just standard form.
Yep. And if a term is missing, you have to put a 0.
So if we went like 4, 2, you'd have to put a 4, 0, 2.
Yeah, because it would be like x to the 4th, and then there's no x cubed, so I'd put 0x cubed. And we'll look at that. And that's really important now, and then getting into synthetic division, which comes later, but works very similar to synthetic substitution. Okay. And you can always check each of these by the other method. You'll get the same answer either way. So if you're like, I'm not super confident with my synthetic substitution by the time the quiz rolls around, you can always check it using the other method. And then that way you'll know, like, hey, I got this, or no, I didn't. And then you can go back and figure out what's wrong. So 16, we've got f of x equals 8x to the 4th plus 12x cubed plus 6x squared minus 5x plus 9. X equals negative 2. So when I know I'm doing synthetic, the first thing I'm always going to look at is, are my terms in order? So I've got 4th, 3rd, 2nd, 1st, 0. And that's the other big one, is a missing term can also be your constant term at the end. Okay? So just make sure you're aware of that. We have all of our terms here. So what we do is we take the coefficients in front of them with their signs, and we're going to write all of those down. But first I'm going to take this number and put it in a box up here in the corner. So negative 2, and then I put it in a, well, like a half box. Then I'm going to write these numbers down in order with their signs. So if it's not in standard form, I would write it in standard form just so you don't get confused, but this one is, so we're good. Leave a gap between them. If it's positive, I don't really write the plus sign, but if you want to, you can. All right, first thing we do is you bring down that first number that's not in the box. So whatever your leading coefficient is of your polynomial, that's always going to get brought straight down. Then we take this and we multiply it by what's in the box, and then that goes under this next thing. So 8 times negative 2 is negative 16. So that goes under the 12. 12 minus 16 is negative 4. So we come down here.
And then we just keep going.
Yep. Negative 4 times negative 2 is positive 8. 6 plus 8 is 14. And I'm with whatever signs are on there. It's not like I'm always subtracting or I'm always adding. It's whatever signs are on the terms.
Wait, you say 12?
What?
Wait. If it would be plus, wouldn't it? Oh, never mind. I'm being stupid.
I was very confused. 14 times negative 2 is negative 28, so that goes here. And I usually just say minus 5 because, you know, whatever. So that's negative 33 times negative 2 is positive 66, plus 9 is 75, and that's your answer.
Oh.
That's a lot.
So once you understand how it works, this probably is going to become your preferred method because it's a lot easier because you're only dealing with like 2 numbers at a time versus up here you're adding
Do now.
all of these numbers together and squaring them and doing all the things.
I like this one.
18, h of x is equal to negative 8x cubed plus 14x minus 35. X is equal to 4. So first thing, is this in standard form? Descending order.
Yeah.
Yes. Am I missing any terms?
Yes.
What term is missing?
2.
Okay, the x squared term. So what I would do is I would usually rewrite this, especially right now as you're getting used to it, negative 8x cubed plus 0x squared plus 14x minus 35. As you go, you may not need to do this, but you need to at least make a note, like mentally, of, okay, I'm missing my x squared term, so I've got to put a 0. Because most of the time when people get these wrong, it's not because they can't multiply and then add. It's because they've forgotten a term, and you'll get a totally different answer if you don't have that 0 in there. So 4 goes in the corner. Then numbers in order. Got negative 8, 0, 14, and negative 35.
What's 8 times 4?
So bring down the negative 8. Negative 8 times 4 is negative 32. Plus 0 is negative 32. Times 4, 8, 12. Negative 128 plus 14 is negative 114. Times 4.
456.
Yep, and it's negative. And then minus 35, so then we just add the numbers because they have the same sign. 11, 9. So negative 491.
Wow.
That's a great number.
Um, 20. After this one, if y'all want to see another one, we can do another one. If you feel like you're good, then we'll halt. So, all right, g of x is equal to 6x to the 5th plus 10x cubed minus 27, and x is equal to negative 3.
We're missing 2 terms.
Yep. So I'm missing x to the 4th. I'm actually missing 3 terms, it looks like. So I'm missing x to the 4th, so I'm going to do this. I'm just, instead of writing the whole thing, I'm going to write 0x to the 4th. Then I'm going to write 0x squared, and then I'm going to write 0x. And I'm going to know that all those go in. If you want to rewrite the whole thing, you can do that. But a lot of times I'll just fill in kind of like where my missing terms are. All right, so we've got negative 3 in the box. And then I go across, I've got 6, then 0, then 10, then 0, then 0, then negative 27. So your highest powered term, you should always have one more number than whatever your highest powered term is for when you're looking here. So this is a raised to the 5th, so I have 1, 2, 3, 4, 5, 6 numbers here. So that's kind of my okay, I got all my, I have all my zeros. It's just another way you can check it.
Do you even need to add the zeros since they don't really do anything? I mean,
They do.
I'll show you after this what happens if you don't put them. I'll show you, because that way you can see what will happen.
They're very important.
All right, bring down the 6. 6 times negative 3 is negative 18, plus 0 is negative 18, times negative 3 is positive 54, plus 10 is 64, times negative 3 is negative, 12, 18, 19, 192.
And then what's 192?
Times negative 3, let's see.
576. I think. I wouldn't trust
I
my
think
math.
so.
Oh.
576, and then times negative 3. 18,
Oh my gosh.
22,
I'll leave this one to you.
negative 1728, I think. Minus 27, so those have the same sign, so I can just add 15, 5, 7, 1. So negative 1755. So my negative sign got covered up.
That's a great number. Can't wait.
So if I didn't put my zeros,
Yeah, I see what I already know. Because you're not multiple. You aren't getting those extra multiplied by
Yep.
So we would just go down to the range.
My number would be off by a whole lot
Just a little.
if I did it that way. All right, do we need to see another one of those, or are we good?
Good.
All right, the last thing in this section is in behavior, which is your very, very brief introduction to limits that'll be coming next year. Essentially, my little catchphrase for in behavior for where you're at right now is what happens as x gets really, really big and really, really small. Okay? So,
You mean really, really small, do you like decimals or negative?
negative. Like negative infinity.
Oh, yeah.
All right, so 28. Describe the in behavior of the graph, the polynomial function, by completing the statements. And so I'll show you how we're going to write them. But f of x is equal to 10x to the fourth. So anytime I'm dealing with in behavior, I only care about the highest powered term. This particular problem only has one term, so it doesn't matter. That's all I'm dealing with. But if it was a whole string of things, say like this previous problem, I only carry about 6x to the fifth. Okay, or up here, negative 8x cubed. And the number in front of your highest powered term matters too, because that can change the sign. So we look at the limit as x approaches infinity of f of x.
Whoa.
And we're also looking at the limit as x approaches negative infinity of f of x. Okay? So when I'm thinking about infinity, that's a kind of hard number to really think about, like, okay, because infinity just goes on forever.
It's
So-
really hard for me to draw an infinity sign.
It's a sideways 8.
I know, I have to get my page.
Some people, like, just draw two circles together. I don't know. Up to you.
It's okay.
Um,
Because if I try to draw it,
yeah, just turn your paper sideways and draw an 8.
it
It's fine.
doesn't, it becomes an 8.
All right, so I only care about the highest power, and I'm thinking about a number, like infinity is hard to comprehend, so I think about, I mean, in this sense, I could literally think about like positive 50 because it's so big, it doesn't really matter, but a lot of times I'll tell people to think like 500. Like if I plugged in 500 for x, what happens? And I don't need the number, I just need to know, is it getting a really big positive number or a really big negative number?
Positive.
Really big positive number, so this is positive infinity.
Oh.
And that's the answer.
And then the next one's negative infinity.
So if I plug in negative 500 and I raise that to the fourth, what's going to be on the sign of that one?
Positive.
Positive. Sign in front is positive. That's why the number in front matters. So that's a 10. So this is also going to positive infinity. Now, another trick that I will tell you is even powers. Okay, so 2, 4, 6, 8, so on and so forth. They are going to always have the same answer. Both of these are going to positive infinity. If they're odd powers, like 1, 3, 5, so on and so forth, they're going to be opposite. One's going to be going to positive infinity, one's going to be going to negative infinity. Okay, and again, this is your very baseline intro. We'll have other problems next year where you have fractions and you have to figure out what's happening to them. That's not right now. These are your basic, very intro problems. All right, 30. F of x is equal to negative 2x cubed plus 7x minus 4. So I only care about the highest power term. Always look and make sure it's in standard form before you do that. This one is, so I only care about negative 2x cubed. So sometimes what I do, instead of writing f of x here, if you want, you can write the limit as x approaches positive infinity of negative 2x cubed. You can write f of x, it really doesn't matter to me. But if you just want to think about your highest power so you're not worrying about what's happening elsewhere, all this stuff is meaningless at infinity, right? Because this is going to way overpower everything else. So if I plug in positive 500 and I raise it to the third power, all I care about is it positive or negative?
Negative.
Just the x cubed part.
Oh, still.
Still positive. Plugged in a positive number
Ah.
to x, okay? Now, it's being multiplied by a negative number, so it's ultimately negative. So this one is negative infinity. Now, this is an odd power, so that means if one's negative, the other one should be positive, but I want to check that, obviously. Don't just automatically write it down, because if you've done something wrong in your math as you're doing them, then you'll hopefully catch that. So now the limit as x approaches negative infinity of negative 2x cubed. If I plug in negative 500, just for x, ignore the negative 2, negative 500 cubed is what? Positive or negative?
Still negative.
Negative. Times a negative
Makes it
Positive.
makes it positive, so this one goes to positive infinity.
They could've done
All right, any questions about this?
And then finish the sides. Or like Addie like a fish.
it. I catch my fishes too.
It's always fun to see everybody's infinities like in 10th grade and then see them like once you're a senior of like how much better they are by the time because you've been writing them for so long.
I should tell her
You
this.
should just write fish.
All right,
Not you saying.
Let's see.
problems
Hold up.
Look, Addie.
5, 7, 9, 11, 15, 19,
Oh yeah.
and then
And then the rest of the book.
29 and 31. So essentially I've given you 2 of each type. If you feel like you need extra practice with something, obviously feel free to do more than that, but there's your,
May I go pee?
yes, because it looks like you're about to die.
I was trying to hold